more students has to be joined, right? Okay, previous class, which subject it is?
EMTL, sir.
Huh?
EMTL, sir.
EMTL, okay, okay. Okay, what we discussed in the last class?
Transformer couple.
Transformer couple, power amplifier, right?
Yes, sir.
And we have calculated the efficiency and all those, everything we calculated, right?
Yes, sir.
And all of you have written differences between direct coupled and transformer coupled power amplifier.
Yes, sir.
Okay. And today we are going to discuss about a distortion, harmonic distortion. Do you have any idea about distortion? I think screen is visible to all of you.
Yes, sir.
Right. So distortion means if there is any change in the input signal, whatever the circuit you have applied with respect to the amplitude or whatever, so which is called as a distortion, right?
Yes,
It is
sir.
right or not? Hello.
Yes, sir. Yes, sir.
Okay. And coming to the harmonic distortion. Harmonic distortion. So you have applied an input signal, so you obtained the output signal. But whatever the input signal you have obtained with respect to the output signal or same signal has to be there in output. But when coming to the frequency components which are there in the input signal, which are there in the output signal, those frequency components which are not there present in the input signal, this type of distortion is called as harmonic distortion. All of you understood?
Yes, sir.
Okay. So in this, whatever the input signal you have applied, in that particular input signal, whatever the frequency component is there, if the same frequency component is present at the output also, that frequency component is called as fundamental frequency component. Do you know this? Hello.
Yes, sir.
Okay. And not only the fundamental frequency component, but also some of the additional frequency components also present in the output signal, but which is the multiplier of the integer of the fundamental frequency component. For example, let us say this is a signal. In this, which is a fundamental frequency component? So I want to draw two more signals. So whatever we have drawn initially, this is a fundamental frequency component. All of you understood? Hello.
Yes, sir.
So means that harmonic distortion means that whatever the input signal you have applied, same frequency components are also available at the output, and at the same time, in addition to that frequency components are called as a fundamental frequency components. In addition to the fundamental frequency component, some of the additional frequency component is there. That is the multiplier of integer with fundamental frequency component. For example, let us consider fundamental frequency component as f. Okay. What about the harmonic frequency component? 2f, 3f, 4f, these all are harmonic components, harmonic frequency components. Might be the first one is a fundamental, afterwards second harmonic, third harmonic, like that. All of you understood or not? Please say yes or no.
Yes, sir.
Okay, thank you. Now, expression for percentage of harmonic distortion. For example, let us consider as a percentage of distortion. So you can consider, we are going to calculate percentage of harmonic distortion. So here let us consider n number of harmonics are there. Okay, so in this case we have to calculate magnitude of nth harmonic component by magnitude of fundamental frequency component. Sorry, magnitude of fundamental component. Multiplied by 100. And let us consider magnitude of the nth harmonic component as Bn and magnitude of fundamental component B1 multiplied by 100. All of you understood this step? Hello.
Yes, sir.
What happened? All of you are in weekend mood? I don't want to listen the class. I didn't get so many responses. Please raise your hands, all of you. Let us say, okay. So all of you got very good CGPA in your previous semester. Hello.
Yes, sir.
No, nobody will give response, huh? Hello.
Sir.
Okay, all of you had lunch?
Yes, sir.
Yes, sir.
I think all of you are waiting for snacks, right? Right?
No, sir.
But there is no Annapurna here.
No, sir.
No, sir.
Annapurna canteen is there at your home?
No, sir.
No, sir.
Ah. Okay. Shall we move on to the class?
Yes, sir.
Sir.
Yes, sir.
Please come out from the sleeping mode. Okay.
Okay, sir.
So, okay. Okay. If you want to find out for the second harmonic component, so how you can, so for second harmonic component distortion, which is D2, so obviously maximum harmonic component is second, that's why which is B2 by fundamental component B1, magnitude of the fundamental component multiplied by 100. If you want for the third harmonic, so percentage of D3, so which is B3 by B1 multiplied by 100. All of you understood?
Yes,
Yes,
sir.
sir.
Okay. Then how to calculate total harmonic distortion? Square root of
D1.
D1 square or D2 square?
D2 square.
D2 square. Why? Because the first one is fundamental frequency component and so on plus dn square multiplied by 100. All of you understood?
Yes, sir.
Yes, sir.
Now we can calculate for the second harmonic component and second harmonic distortion. Now second harmonic distortion. First of all, transistor is a linear device or non-linear device? Hello.
Non-linear, sir.
Which is a linear device. Now assume that the transistor is non-linear and it is parabolic in nature. Now, how the characteristics will vary? For example, the graph is between IB and IC, so which is in linear actually transistor, but it shows parabolic. Okay. Now we can write IB is equal to, how we can write? IB is equal to, we can write IBM cos omega t. All of you understood? Hello. Hello. Am I audible?
Yes, sir.
All of you understood? Hello.
Yes, sir.
Okay.
Good.
And we can express the IC is equal to G1 into IB plus G2 into IB square for the parabolic. Okay. So IB is equal to IBM cos omega t plus g2 into చెప్పండి అమ్మా క్లాస్ వద్దా హలో క్లాస్ వద్దా ఏంటి ఆ? హలో
Yes, sir.
Yes, sir.
క్లాస్ వద్దా అమ్మా we can calculate
sir.
అమ్మా హలో
Yes, sir.
Yes, sir.
చెప్పండి క్లాస్ వద్దా ఏంటి
Class కావాలి సార్.
కావాలి sir.
మరి మీరేం మాట్లాడరు రెస్పాన్స్ లేకపోతే ఎలా g1 ibm cos omega t plus we can write the cos square omega t as
1
1
plus
plus cos 2 omega t by 2. Then expand g1 ibm cos omega t plus g2 ibm square by 2 plus g2 ibm
Square.
cos 2 omega t by 2. All of you have done up to this?
Yes, sir. Yes, sir.
And now IC is equal to, for the first harmonic motion, sorry, for the fundamental as B naught plus, I am going to consider this one as B1, this one as, sorry, 1 minute. I am going to consider this one as B naught. Okay, this one as B1, this one as B2. Now we can represent this as B naught plus, here the B1 is nothing but G1 multiplied by IBM. So B1 cos omega t plus
B2 cos
Plus
omega t
B2
by
is
2.
this one.
2 omega t.
B2 is this one, B1 is this one. Then B2
B
Cos 2 omega t.
cos 2 omega t. Here the 2 is also mixed with this. Okay. Now IC is equal to IC is equal to, how we can write? So there is a Q point also there for the transistor for the DC operation. That's why we have to add that particular Q point current ICQ plus B naught plus B1 cos omega t plus B2 cos 2 omega t. So here we are expressing the total current in terms of DC bias value and signal component and fundamental component and harmonic component. All of you understood?
Yes, sir.
Yes, sir.
Here we are expressing the IC in terms of DC signal component, DC bias value, fundamental frequency, and second harmonic component also. Now I am going to consider a signal Assume that this is the first point. Assume that which is the second. Assume that which is third. Okay, the entire this is with respect to the omega t. So now what I am trying to represent is I want to find out for I max as well as for I minimum. Okay, at point 1, at point 1 omega t is equal to 0, then IC value, calculate IC. IC is equal to ICQ plus
B0 plus B1 plus B2.
B0 plus cos 0 is 1. So B1 plus B2. This is the expression for IC at point 1 omega t is equal to 0. All of you understood why omega t is 0, which represent 0 with respect to this. Okay. Hello.
Yes.
Okay. Now I am going to consider omega t is equal to pi by 2 at this point. At we can write this as at point 2. So IC is equal to ICQ
Plus B0
B0
minus B2, sir.
minus B2.
Minus B.
Have you understood? Minus 1. Okay.
Yes, sir. Okay, sir.
At point 3. Point 3 is this. How much phase here? Omega t is equal to 5.
Minus.
Now IC is equal to ICQ
ICQ plus B0 minus B1.
minus B1 minus B2. Okay. From the above, at omega t is equal to 0, IC is showing I max, right?
Sir, at point 3, IC plus B2, sir.
Minus B plus B2, sir.
1 minute. ICQ plus B0 minus B1 plus B2, right? Plus B2. Okay. At omega t is equal to 0, the IC is showing maximum value. At omega t is equal to pi by 2, IC is showing ICQ. All of you understand?
Yes, sir.
At omega t is equal to pi, IC is equal to I minimum. So means that it is at point 1, it is at point 2, it is at point 3. Okay. So now we will write the expression. IC is at 1 or at point 1. So IC is equal to I max. Then we will substitute. I max is equal to ICQ plus B0 plus B1 plus B2. All of you understood? Consider as 1. IC at 2. So that value is ICQ. Then ICQ plus B0 minus B2. Consider as 2. IC is at 3. So I minimum is equal to ICQ plus B0
B0
minus B1 plus B2. This
B2.
is 3. All of you understood?
Yes, sir.
From equation number 2, ICQ is equal to ICQ plus B0 minus B2. So ICQ both were cancelled. Then B0 is equal to
B2.
B2. Now substitute B0 is equal to B2. No need to substitute. Now we will try for I maximum minus I minimum. Now calculate I maximum minus I minimum. What is I maximum? I maximum minus I minimum. I maximum is ICQ plus
Plus
B0
B0 plus B1
plus
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 B2
B1
B1
plus
plus
B2
B2 minus
minus ICQ
ICQ
plus
Q
plus B0
B0
ICQ
minus
plus
B1
B0
B
minus
minus
B1
B
plus
plus
B2.
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 Now tell me any or cancel any one of
Yes, sir.
what are the
2B
cancelling terms? Most probably ICQ will cancel. Okay, we'll expand it. ICQ
B0
plus B0 plus B1 plus B2 minus ICQ minus B0 plus B1 minus B2, right? So ICQ cancel, B0 cancel, B2 cancel. So which is 2 B1.
B1.
All of you got this?
Yes, sir.
Yes, sir.
Now B1 is equal to I maximum minus I minimum by 2. All of you understand?
Yes, sir.
Yes,
So we
sir.
can write this one as in peak to values. I peak to peak by 2, right?
Yes, sir.
So this is, we can write it as IM. All of you understood?
Yes, sir.
Okay. From equation number 1. From equation number 1. I maximum is equal to, what is I maximum? ICQ plus
Plus B0 plus
B0
B1 plus B2.
plus B1 we have calculated as, okay, we will write the formula. B1 plus B2. Substitute in terms of B1, I max minus I minimum. Understood?
Yes, sir.
Okay. Then ICQ
IC plus
plus B0 plus B1 is nothing but I max minus I minimum by 2 plus B2. Already B0 is nothing but B2. We have already,
yes,
yes.
sir.
So ICQ plus B2 plus I max minus I minimum by 2 plus B2. All of you understood?
Yes, sir.
Now
Yes,
we can
sir.
write ICQ plus 2B2 plus I max minus I minimum by 2. Okay. Hello.
Yes, sir.
Okay. Now make it as LCM. It's 2, then 2 ICQ 2ICQ plus
4B2
B2 plus I max minus I minimum. Is it right? Which is equal to I max.
Yes, sir.
Now calculate B2. Calculate B2. So cross multiply 2I max is equal to 2ICQ plus 4B2 plus I max minus I minimum. 2I max is 1. Is it right? 2I max minus I max.
I
So
max
I max plus I minimum minus
2ICQ
2ICQ is equal to 4B2. So now B2 is equal to I max plus I minimum minus 2ICQ by 4. All of you understood?
Yes, sir.
So we calculated the second harmonic component. All of you understood?
Yes, sir.
Okay, if you want to calculate the distortion for second harmonic, percentage of D2 is equal to, what is the formula? Modulus of B2 by fundamental B1 into 100. This method is called as 3-point method. This method is called as 3-point method. We have identified for 0, pi by 2 at pi. These are the 3 points, 1, 2, 3. So all of you understood? Hello.
Yes, sir.
Okay. Next, how to calculate power? Power output due to distortion. Is there any change? Is there any change in the output because of distortion? There is a change. Whenever we are talking as a distortion, obviously there is a change. So we can write it as PAC is equal to. Now tell me. చెప్పండి. VM multiplied by RL. Is it right or not? Hello. Hello.
Sir.
How we can write this? Point for expansion. Sorry, we can write this one as directly power V is equal to I into RL. So V into I. So directly we can write this as Im square RL by 2. Hello.
Yes, sir.
Yes, sir.
All of you understood?
Yes, sir.
So power P is equal to V into I. I is nothing but I into R. Okay. All of you understood?
Yes, sir.
Yes, sir.
So, but Im is equal to I peak to peak by 2 is equal to I peak to peak is equal to I max minus I
I
minimum
max minus I minimum
2.
by 2.
And directly for the first harmonic component, B1 is equal to I max minus I minimum by 2.
I
Already calculated.
minimum by 2. Yes, sir.
So B1 is equal to I max by I minimum by 2 is equal to IM. All of you
Yes,
agree?
sir.
Now
Yes, sir.
PAC is equal to 1 by 2 B1 square RL. Hello.
Yes, sir.
So for the distortion for the AC in AC output, how we can represent with 1 by 2 B1 square RL plus distortion B2 square RL plus 1 by 2 B3 square RL plus and so on. Have you understood?
Yes, sir.
Yes, sir.
Yes, sir.
You just make the common as B1 square RL. So 1 by 2 B1 square RL as common. Then 1 plus B2 square by B1 square plus B3 square by B1 square plus so on. So 1 by 2 B1 square RL is equal to 1 plus B2 square by B1 square.
D2 square.
Simply you can write this one as D2 square
D2 square.
plus
D3 square.
D3 square plus and so on Dn square. So PAC distortion is equal to PAC distortion is equal to, you can write this one as 1 by 2 B1 square RL is nothing but PAC multiplied by 1 plus D square. All of you understood?
Yes, sir.
All of you understood the entire derivation?
Yes, sir.
Yes, sir.
Okay. Thank you. Do you have any doubts?
No, sir.
Yes, sir.
Okay, if you have
No,
any
sir.
doubts, please raise your hands.